number 17. So part B. So this is asking for the median. So find the median. And our function that we had an exponential random variable. And so it had the PDF was f of x equals a e to the minus ax, and the CDF, which we found in part A, was 1 minus e to the minus ax. Okay, so our graph looks something like this, and we're interested in finding the median. So the median is the boundary that's going to cut it into two parts of half on this side and half on that side, but it's the boundary. And for this one, I'm going to call it M for median. So the median boundary. So, and I'm just going to use the CDF directly on this. So the CDF formula. Remember, the CDF tells you this probability. So it tells you the probability of the random variable occurring for a specific upper bound. And so since we want that to be a half, we're just going to proceed with this formula. So we want the probability that x is less than or equal to our median value. So that's our input to the CDF function. So it's 1 minus e to the minus a times m. Okay, and now we just need to solve for this value here. And then we'll know what the median is. So first up, subtract 1 from both sides. So we have half minus 1 is going to equal minus e to the minus a m. So this is minus a half. Next, these will go. So we get 1/2 equals e to the minus am. All right, now we want to pull this power down. So take the log of both sides. And so what that lets us do is take this from the exponent and pull it in front. So, and then it's a times there. So we have ln of 1/2 equals minus a m natural log of e. The natural log of e is 1, so that simplifies this. So we have minus am equals ln of 1/2. So m is going to equal ln of 1/2 divided by negative a. All right, so you can compute that now, or you can realize that you can pull the minus sign to the half a m, and then this will make it, if you pull that in, that's the same as raising this half to the minus 1 power, so it'll flip it. So it's ln of 2 over a is your median. But if you computed it at this stage, you'd also get a correct answer. But this is just a little simpler.